Hi everyone. I wanted to make a screencast for you to show you how to do correlational analysis and scatter plots using a different but really interesting data set that I found in my Facebook feed a few days ago. So I encourage you to have a look at these graphics. So if you go to www.bloomberg.com/graphics/2015 What's Warming the World, there are really interesting simulations of the kinds of variables that people point to when they're talking about climate change, but they also provide with the raw data. So I've downloaded the raw data, and it's actually perfect for doing correlational analysis and looking at the strength of different relationships. So let's have a look at the data set. So if you open the data set in SPSS, this is kind of what it looks like. So we have the year from 1851 all the way down to, how far does it go? 2005. And we have annual observed temperature changes from year to year, and then factors that people point to in terms of potentially natural causes of climate change, like orbital changes and changes in solar activity and changes in volcanic activity, and then human-driven factors that might be causing climate change, like ozone and land use and greenhouse gases and aerosol use. So let's have a look at the correlation between increases in annual temperature and the natural variables that people point to when they're talking about climate change. So if we go analyze and then correlate and then bivariate, and then we can put in, using this little arrow, just put in all the variables that you want to have in your correlation matrix. So we have annual mean observed temperature first, and then if we put in orbital changes, solar and volcanic, what you can do is ask it to give you means and standard deviations at the same time, which is useful. If you go options and then choose extra statistics, and then we want to choose Pearson and two-tailed tests, and it's going to asterisk the significant correlations for us, which is helpful. So we go OK, and what we end up with is our descriptive statistics at the top, and then a correlation matrix that shows us the extent to which annual mean temperature is related to changes in orbit, changes in solar activity, and changes in volcanic. And so the ones that are significant are tagged with little asterisks. So you can see that there's no relationship between orbital changes or volcanic changes and mean temperature, but changes in solar activity is significantly correlated. Now, correlations are generally between 0 and 1. A 1 is a perfect correlation and 0 is no correlation. And we generally say that correlations of around 0.4 are of a small to medium size. So this is a very respectable size correlation for a psychological study. And what it says is that increases in whatever they measure, solar activity, go up in hand with increases in temperature, which is interesting. Okay, so let's have a look at the human factors instead. We'll go correlate and bivariate, and then we'll take out these natural factors using the arrow and throw in aerosol use, greenhouse emissions, land use, and ozone. Again, we'll ask it to give us means and standard deviations, and then go OK. So you've got your descriptors at the top, and then you can see that the magnitude of these correlations are on a different scale. So when we have positive correlations like this one, 0.923, that's about as big as correlations ever really get. So increases in temperature are really tightly related to increases in greenhouse gases. We also have a positive correlation between observed temperature and ozone, not quite as big, but still a correlation of 0.76 is much bigger than you typically see in psychological studies ever. And then aerosol use and land use are negatively correlated. So we have negative 0.87 and negative 7. So that means that increases in mean observed temperature go hand in hand with decreases in aerosol use and decreases in land use, which is interesting.